Hi guys, so now we'll be discussing about course schedule 2 problem. There are some courses given which you are supposed to take and it's labeled from 0 to number of courses minus 1. In this case, we are supposed to complete the prerequisite courses first before completing the next course. For example, it shows that you should take one first course before 0th course. So we are supposed to return the ordering of courses in order to finish all the courses, and if it's impossible, then we have to return empty array. So let me show you by the example 2. This is the graph. The prerequisite graph will look like this. So here, in order to complete all the courses, we can't jump to course 3 or 1 or 2 before doing the course 0. So it's basically a directed graph and we have to start from the node which has no node pointing to it. So here, after you complete node 0, we can choose either nodes 1 or node 2, which are the courses. Like here, 0 is the prerequisite course for 1. Similarly, 0 is the prerequisite course for 2 and 1 is a prerequisite course for 3. After completing 0, we choose 1 and we complete one course, and we can now complete course 2. After both 1 and 2, we can complete course 3. Now for example, instead of pointing here, this node was pointing here. In this case, we cannot start any course first. For course 0, we should complete course 2. For course 1, we should complete course 0, and for 3, we should complete either 1 or 2. So in this case, it's not possible, so we'll return an empty array. That means we cannot finish all the courses. So this is the problem, and we need to, it's basically a graph problem where we need to traverse all the nodes but in an order. In usual DFS or BFS, what we do is we start from a node and we traverse its neighbors randomly and go on and on. But here we need an order. So the best algorithm for graph traversal with an order is topological sort. So let's see how topological sort will work for solving this question. So according to the courses and the directions, we are supposed to choose 0th course first, right? Because there is no prerequisite course for 0. This also indicates that there is no in degree for the node 0. We have 1 in degree for 1, 1 in degree for 2. That is the number of incoming edges, but no incoming edges for 0. So we will use this concept where I will start my traversal from the node with 0 in degrees, and I will keep removing that node from this graph one by one and also deleting its edges. So let's first check the in degree of all the nodes. 0 has a 0 in degree, 1 has 1 incoming edge, and 2 also has 1 incoming edge. 3 has 2 incoming edges. So now we will start from the node with 0 in degree. A graph can have multiple nodes with 0 in degree, so we can start from any node in that case. Here I will insert the nodes with 0 in degree in my queue to start the traversal. After this, I will be deleting this node from the graph and also the edges which are connected to this node. By removing the edges, we can subtract one incoming edge, that is in degree, for these respective nodes. That means for node 1, we will reduce the in degree, and also for node 2. Now what happens? Now we got 2 more nodes with 0 in degree, and we insert those 2 nodes in the queue and pop them one by one. So first I pop 1. That means I'm deleting this node and also the edge related to this node. That also means that the in degree of 3 is reduced by 1. Now only 2 is in the queue and 3 still has 1 in degree, so I cannot add it to my queue. Now I will delete the node 2 and also its edge pointing to 3, which reduces the in degree of 3 to 0. Lastly, I have 3 here, and 3 has been removed. So this is my topological ordering, where I started from node 0, then I completed 0th course and went to 1, then I completed 1 course and went to 2, then I completed second course and went to 3. So I got this order which is required in the question, and the same thing has been reframed as courses. So wherever there is ordering required, we can use this topological sort, which is also known as Khan's algorithm. So let's code it now. So first we'll create the graph using the given info of prerequisite nodes and requisite nodes. Num courses. Next we will have one in degree array, which is initialized to 0 for all the nodes. Courses. Now for creating the graph, we have the prerequisite course and the courses. So prerequisite and course in prerequisites. So graph of prerequisite dot append the course, and also we will increment the in degree of our course, by 1. Next, now we also need a queue, and after we have created the graph, we have to check the nodes which have 0 in degree. So for j in range of numCourses, if graph of j, if in degree of j is equal to 0, then append it to my queue. Next is the final traversal. So for node in queue, for k in g of node. This is for the neighbors of this node. So as I'm going to delete the node, I will first decrement the in degree of the neighbors. Then I'll check if the in degree of this node has become 0, then I'll append this node to my queue. So I append it to the queue, then again this loop will traverse until queue is not empty, and I'll be decrementing the node in degree every time I select that node of the course. That means here this node is nothing but we are removing this node from the graph, indicating that we have completed this course. Now we can't remove the node physically from the graph, so we are using this concept where we are selecting the node and reducing the in degree, which indicates that the node has been completed, the course is completed. So after this, my queue is nothing but the order of the graph, right? Because initially we appended the first node, that is j. Every time we are appending that node to this queue, so instead of popping that node from the queue and using another list variable, I have used this queue where I'm appending the node every time the in degree is 0. So this will be the final ordering of the graph. So now instead of just returning this queue, it's important to check if this queue has all the nodes. That means if my course has 4 courses to be completed, if my input has 4 courses and my order also has 4 courses, that means I have completed all the courses. If that's not the case, if there's only 3 courses out of 4, then I'm supposed to return an empty array because I have not completed all the courses. So I will check if my length of queue is equal to numCourses, then I return queue, else return empty list. Okay, it worked for the sample test case. Let's try to submit it. Yeah, so it worked for all the test cases. I didn't get any error this time because the concept was straightforward. The first step is to make the graph and in degree list. Second step is to check and add the in degree of nodes, add the nodes with in degree 0. And the third step is the basic traversal, where we reduce the in degree of the neighbors of the node which we are currently in the queue, and then we add that in the queue and we traverse the entire graph. Lastly, we check if all the courses are completed or not. So this was course schedule 2. That's all. Thank you.